A magazine store recorded the number of magazines purchased by its customers in 1 week. 23% purchased 1 magazine, 38% purchased 2, 21% purchased 3, 13% purchased 4, and 5% purchased 5. We need to find the mean of the magazine store data, so find the mean number of magazines, and we need to explain what this actually means. So if we say we're talking about discrete random variables, so the expected value EX is the mean, mu, exactly the same thing, and we know that mean, mu, is the sum of all the x times p x equals x. So this capital X is a random variable, it's a discrete random variable. In this case, let x be the random variable. So it's the number of magazines purchased. Okay, so what we're going to do, we're going to set up, or we're going to describe the probability distribution, and we're going to use a table for that. So here we have our x's, and then we have our p x equals x. So as is often the case in probability, you don't necessarily have an actual probability. In some cases, you can get a theoretical probability, simple things like coins and dice, but in the vast majority of cases you have to use past data to get estimates of probability. In this case, we've got data collected over this 1 week. So the different values of x that the customers, the different numbers of magazines that the customers bought range from 1 up until 5. Because it's a magazine shop, everybody bought 1, so there's nobody who didn't buy 1. So we have 1, 2, 3, 4, and 5. So what we're going to do, we're going to just convert these proportions into probabilities. Effectively, we're treating them as relative frequencies. So what I mean by that, if 23% purchase 1 magazine, we're going to assume that the probability of x being 1 is 23%, 0.23. So for 2 magazines, that would be 0.38. 3 magazines is 0.21. 4 magazines is 0.13. And 5% for 5 must be 0.05. So there's the distribution. Now we know that the mu, or the expected value, which is the same as the mean, is, so mu is the sum of all the x times p x equals x. So it must be 1 times 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. So 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. Okay, so that comes up with 2.39. And that is our mean. And then it asks us to explain what this means. So what that means is interpret it in the context of the question. So what it doesn't mean is that somebody's going to come in and buy 2.39 magazines. That obviously doesn't make sense. But what it means is over a period of time, assuming that this data is a reasonable representation of the actual of typicality in this magazine shop. Over a large sample size, the mean number of magazines sold would be 2.39. So say you had over a whole year, if you counted the number of customers and times that number by 2.39, you would hope that that would be close to the amount of magazines you actually sold. So it just means, on average, each customer buys 2.39 magazines. So even though it's obviously impossible to do that, statistics like this, they're really, really useful for forward projections, thinking about how much money you're going to make, or what sort of stock you're going to need in, that sort of thing. Also, I should say that we don't necessarily have to do this. I could have used our frequency table approach as well. So if we had gone to menu statistics and just sort of put them in, so 1, 2, 3, 4, 5, and just put the probabilities in, 0.23, 0.38, 0.21, 0.13, and 0.05. If we just put it in like that, go to set, tell it it's a frequency table, so the X list is list 1 and the frequency is list 2. Now you're thinking, well, these aren't frequencies. Well, they're not frequencies, but they're relative frequencies, so that it will do exactly the same thing as far as the calculator goes. If I then press one variable, I still get this mean of 2.39. So it's going to be a calculator question anyway, something like this. So you might as well use the calculator functions, unless, say, you get a question like this for quite a few marks. Maybe you need to show some work in, but it's quite a generous question anyway at HL.